Okay, so in this next example, notice that I did not call the inverse function g. We actually wrote out f inverse.
Oh, so it's just the same thing?
It's the exact same process. I just need you to see the difference in notations. And this gets tricky. Don't go too fast writing it, because if you're flying through this and you're writing, you might switch these two around and end up saying something completely different. So I just need you to see the different symbols. Yes, sir, Bennett?
Would that be a one-to-one function?
Is this a one-to-one function? Graph it on your calculator and look at it and see.
I mean, I know it's like...
Check it.
Are there no intervals that you...
Check it. I did not have a domain restriction written down for this one, so I think that it's one-to-one. Yeah, it is one-to-one. I thought I'd been pretty good about writing my domain restriction. So good. That's a good thing to check, Bennett. Because if it's not one-to-one, then can you find this? No, you can't. So you should definitely be checking that condition. Sometimes it does loop and come back down, but this one does turn out to be a one-to-one function. Okay, so thanks for checking that. Okay, so if I'm trying to find the derivative of the inverse at 2, that'll turn into 1 over the derivative of f at the inverse of 2. So do you want to go with it on your own and try to figure out, do those two calculations that you need to? If you'd like to, go ahead. If you don't want to do it on your own, then look up here as I do it. So we've got an equation here that's pretty difficult to solve. You don't want to try this one again? AP Board is really good when they give you questions like this about choosing equations that are very simple to solve using guess and check. Okay, so they don't give you problems that are so complicated you can't find out what this value is. A lot of times this will show up on a non-calculator portion of the test anyway. So it's going to be some easy number. Give me a good number that you think might solve this equation.
3.
Okay, I was thinking really easy numbers. I would start with 0, and then that doesn't work, so then let's try 1. 4's a fine number to try, but you skipped a whole lot before you got to 4. Plus 4 to the 5th minus 4 cubed, that's pretty calculator or calculation intensive. Does 1 work? 1 minus 1 plus 2 equals 2. So x equals 1. So the inverse... Yeah, that's not something you would factor because it needs to equal 0 first, and then factor by grouping doesn't help us here. So we find out that the inverse of f at 2 is 1. What is the second calculation that we need to perform? Find the derivative of the original function. So we need to find the derivative of f, which is easy to do. What is that? 3x squared. And now what value did I want to input here? We want to input that value 1 that we just found. So when you put 1 in, what do we get? 4. Good. So then this just turns into 1 over 4. Okay, you good for the next example? Okay. So let's try our next example. So suppose G is the inverse of F. And I'm not giving you functions this time. I'm just giving you a couple of data points. So f of 2 is 9. The derivative of f at 2 is 3/4. And I want you to find the derivative of g at 9. So using my formula, doesn't that mean this would be 1 over the derivative of f at g of 9? Did the problem explicitly define what g of 9 is?
No.
But shouldn't you be able to figure that out from the information that you're given?
Yes.
If f of 2 is 9, then what is g of 9? 2. Okay, so that's what we have to gather from the information. So then this just turns into 1 over the derivative of f at 2, and didn't they give me that information? So this is 1 over 3/4, which turns into 4/3.